This is video number 4 for sections 6.1, 6.2, and 6.3, dividing polynomials. Dividing polynomials is not quite as useful as adding, subtracting, and multiplying, so we won't end up using this a lot, and therefore we won't get into this too deeply. I'm just going to show you two types of problems here. The easiest kind, and certainly the most useful kind, is the situation like in this first example where you are dividing by a monomial. In other words, the one on the bottom only has one term. This turns out to be pretty simple because really all this is an application of the distributive property. This one on the bottom just needs to be distributed into the other three terms. As far as doing the work and writing it all out, I would suggest you do it in two steps. The first step would be to simply write down the three individual division problems you're going to do. What I like to do when I'm doing that is decide on the signs also. So for example, this first one I have a negative divided by a negative. Well, I know that's a positive, so I don't really need to worry then about the sign. And I'll just write 2b to the fifth on top and 3b to the third on the bottom. And then for the next one, let's see, I have a positive divided by a negative. A positive divided by a negative is negative, so I'm just going to write one big minus. That's done. And then I just need to write down the division problem again. It would be 9b to the fourth over 3b cubed. The final one is again a negative divided by a negative, which is a positive, so I'll write a big plus. And then I copy down the division problem again. Notice I haven't been writing negative 3b cubed because I took care of that already. I already thought about how the final signs are going to turn out. All that's left now is just to do some simple canceling of common factors. When you look at this first guy, for example, 2 and 3 do not share any common factors, so nothing I can do there. But I've got 5 b's on top and 3 b's on the bottom. Well, 3 of the b's on the bottom will cancel out with 3 of those ones here, leaving me with 2 left. I suppose you could think in terms of rules of exponents as well. But it's honestly probably easiest to just think in terms of canceling. Let's see, the next one, this time the coefficients, I can do some canceling. 3 goes into 9 3 times. And then with the b's, I've got 3 on the bottom, 4 on the top. All 3 on the bottom will cancel out all but one of the b's on the top. This one, there's nothing left on the bottom, so it's not even a fraction anymore. It just came out to be 3b. And then the last one, let's see, what kind of canceling can I do here? 3 goes into 15 5 times. That's easy. And this time I'm going to end up with more b's on the bottom, aren't I? Because I only have 1 on the top. That 1 could get rid of one of these, leaving me with a couple on the bottom. We don't want any negative exponents in these answers. This is why I think the canceling idea works the best. It looks like I ended up with a 5 on the top and then b squared on the bottom. This is the final answer to this division problem. And again, we just got it by distributing the original denominator into all three pieces. Okay, the second situation is unfortunately a bit more complicated. It is the situation where you want to divide not by a monomial, but by a binomial. And unfortunately, there just is no great way to do this other than good old long division. When I say that, I mean you got to think way back to just dividing whole numbers using that long division process. It's a very similar strategy that you have to take to work a division of polynomials problem. I listed for you here a basic reminder of the steps. It's how many times does 3 go into 19? Well, that'd be 6. Then I multiply 6 times 3. Then I subtract, and then I bring down, and then I start over again. How many times does 3 go into 14? Well, that'd be 4. And then I multiply, and then I subtract, and when there's nothing left to bring down, I take my remainder of 2 and I put it over the divisor of 3, and the final answer to this problem would be 64 2/3. That same long division process is what I need to do for this example. Let me set it up with the division symbol. I'm taking that trinomial and dividing it by this binomial. Well, let's run through our long division steps. The first one is goes into. Now, when you're doing this with polynomials, you simply look at the first term here and the first term here. How many times does 2x go into 8x squared? And really all that means is, what would I have to multiply by 2x in order to get 8x squared? Well, hopefully you can think about that for a second and realize that the answer would be 4x. 4x times 2x is 8x squared. That's the goes into step. Then you multiply 4x times now the entire binomial. So 4x times 2x plus 6. Well, the first term is just going to match because we set it up that way. And then 4x times 6 would be 24x. So again, the goes into step, just the first one here with the first one here, but the multiply, I do the whole thing. Okay, then I need to subtract. You have to be careful here because you need to subtract all of this stuff, which means all the signs change. I need to go take away 8. I need to go take away 24. If it had been a negative already, the sign would have changed to a plus. So make sure you're changing those signs when you subtract. These guys disappear. 26 minus 24 makes 2x, and then I'm at the final phase, which is bring down. Bring down my next item, and then you start all over again. Goes into first term here, first term here. How many times does 2x go into 2x? In other words, what do I multiply by 2x to get 2x? Of course, it is positive 1. Then I multiply. When I multiply everybody. 1 times 2x and 1 times 6. Then comes subtract. Change all the signs. Whatever the signs were, change them to the opposite here. That makes these both minuses. And then when I actually do the subtraction, these guys disappear. I have positive 7 take away 6, which is positive 1. I don't have anything left to bring down. That means the 1 is my remainder. And I finish this off by adding to this the remainder over the divisor. I didn't need to put a plus in the 64 2/3 because mixed numbers, that's understood, but in the algebra situation I need to include that plus there. This is the final answer to the problem. You say, how in the world do we interpret this? All we're saying is this. If you were to multiply, remember multiplication is the reverse of division, right? So if you were to multiply this 2x plus 6 by this 4x plus 1, you would almost get 8x squared plus 26x plus 7. You'd be just 1 off, is what the remainder is trying to communicate. Again, we won't be using this a ton, but you are going to have to practice this on the homework in order to learn the skill.